Hello students, welcome to the next lecture of 11th chemistry, chapter number 13, nuclear chemistry and radioactivity. Now we have come to the last topic of our chapter, that is we are going to study applications of radioisotopes in this lecture. So there are 4 applications. First of them is radiocarbon dating. Now let's understand what is this radiocarbon dating. Now this radiocarbon dating is used to find the age of any historic or archaeological samples. We know that scientists or archaeologists study history, and while studying the history they want to know the age of that sample. So this radiocarbon dating is very useful to them. They find the age of wood or even animal or human fossils. Scientists, we know that how do they find the age of the human fossils or animal fossils which are found? They use this technique, radiocarbon dating, to find the age of that sample. We know that the carbon-14 isotope is radioactive. Okay, isotope of carbon having mass number 14 is radioactive. Now this carbon-14, it is formed in upper atmosphere of our Earth due to the bombardment of neutrons. Okay, and these neutrons are received on the Earth due to the cosmic rays. आपल्याला माहिती की cosmic rays आहेत आपल्या space मध्ये. Okay, where do these cosmic rays come from? These cosmic rays come from the sun, from other galaxies also. Okay, वेगवेगळ्या गॅलेक्सी मधनं आपल्या सोलर सिस्टम मधनं हे जे कॉस्मिक रेज असतात त्याच्यामध्ये you have neutrons. Okay, you have neutrons in the cosmic rays which help in the formation of this carbon-14 isotope. Now we know nitrogen is present in the atmosphere, so these neutrons from the cosmic rays, they bombard on the nitrogen and give rise to your carbon-14 isotope along with hydrogen. Okay, so this is the reaction. You can see nitrogen mass number 14 and atomic number 7. When it is bombarded with neutron, you get carbon-14 isotope and hydrogen with atomic number 1 and mass number 1. Now this carbon-14 isotope, this combines with oxygen, atmospheric oxygen, the oxygen which is present in the nature. Okay, it combines to form carbon dioxide which is having carbon-14. Okay, so this carbon-14 which is formed over here in the nature, it combines with the atmospheric oxygen to form CO2, that is carbon dioxide, which is having carbon-14. Okay, now this carbon dioxide, it mixes with your normal carbon dioxide. This mixes with your normal carbon dioxide. Okay, this mixes with your normal carbon dioxide, and this carbon dioxide is then absorbed by plants during photosynthesis. We know that plants use carbon dioxide for making food, and then what happens, these plants absorb the carbon dioxide having carbon-14 isotope during photosynthesis, and in this way this 14 carbon becomes the part of our animal and plant bodies. Okay, in this way they are absorbed. It is absorbed in food, and this food, when we eat, human beings or animals, this 14 carbon is introduced into their body. Now this, as long as the plant is alive, okay, as long as the plant is alive, this ratio, carbon-14 to carbon-12 ratio is constant. It is a constant ratio. But as soon as that plant dies or that tree dies, what happens? This ratio begins to decay. This ratio becomes to decrease. Why? Because your carbon-14 starts to decrease. Okay, so let's see what happens. Now this carbon-14 decays, giving out your nitrogen and electron. Okay, So this carbon 14, what did we say? That as long as the plant is alive, जोपर्यंत तुमचं ते plant जिवंत आहे, तोपर्यंत what happens? Your C14 to C12 ratio remains constant. हा ratio आहे हा constant राहतो. But as soon as your plant dies, जसा तो plant dead होतो, what happens? Your ratio begins to decrease. Why? तुमचं कार्बन 14 आहे ते रेडिओ असल्यामुळे ते काय होतं? इट स्टार्ट्स टू डिसइंटिग्रेट और इट स्टार्ट्स टू डिके. ते डिके व्हायला लागतं आणि डिके होताना ते काय करतं? व्हॉट हॅपन्स? हाऊ डज युअर कार्बन 14 डिकेज? इट डिकेज टू गिव्ह यू नायट्रोजन and it liberates it emit one electron also. Now T half of your this 14 carbon, okay, half life of this carbon is 55730 years. Okay, so now you can imagine what happens when the plant is dead. Now this activity, next point is the activity. Now activity, that is the activity N. So the activity, let the N be the activity of your given wood sample. How the scientist will calculate? Let's see. N is the activity of the given wood sample, the sample which scientists have found. What will denoted the activity of that sample will be denoted by N. So what will be N0? N0 will be the activity of fresh sample. Same plant का जो fresh sample असेल, जी live असेल, त्याची activity आपण N0 घेणार. आता हीच N0 आपण काय सांगितलं? What did we say? As long as your plant is alive, the ratio is same. Carbon 14 to carbon 12 ratio is same. So this N0 activity is same activity. The fresh sample ची activity जी N0 आहे ती कोणाबरोबर same असणार आहे? It is going to be the same given by the plant at the time of death. ज्या प्लांटचा आपण सॅम्पल स्टडी करतोय त्याची ऍक्टिव्हिटी जेव्हा तो मेला, जेव्हा ते डेथ झाले किंवा इट हॅज गॉन, इट हॅड बिकम डेड, इट वॉज नॉट अलाइव्ह, त्याची जी ऍक्टिव्हिटी काय असणार आहे ती N0 असणार आहे. आताची जी फ्रेश सॅम्पलची ऍक्टिव्हिटीज आहे तीच त्याची जेव्हा तो डेड झाला तेव्हा तीच ऍक्टिव्हिटी त्याची असणार आहे. Okay, so this N0 is nothing but the activity of fresh sample and it was the activity of the plant given by that at the time of the death. You can say like this. Okay, so the next point is now the age of the sample. Let's see how the age of the sample is being calculated. We know that T is given by 2.303 upon lambda log to the base 10 N0 by N. We have seen this equation. Okay, we have seen this equation that how you can calculate the T. T is the age of the sample. T is the age of the sample. So how you can calculate? You can calculate using the decay constant formula, that is T is equal to 2.303 upon lambda into log to the base 10 of N0 by N. Now we know N0 is nothing but the activity of the plant, the fresh sample, and N is the activity of the current wood sample. Now lambda can be calculated as using the T half. We know what is the T half of carbon 14. Just now we wrote 5730. So this turns out 1.21 into 10 raised to minus 4 year inverse. This is in years. Okay, T half is given in years, so lambda is nothing but 1.21 into 10 raised to minus 4 per year. This on substitution, here you have to substitute the N0 and then you will get the age of that plant. Okay, in this way the scientist or archaeologist find out the age of that sample. Okay, now moving on to the next application. Radioisotopes are also used in medicine field. So let's see how they are used. So next application of radioisotopes is in medicine. Now many hospitals, they have different department regarding your nuclear medicine. Nowadays we know that cancer is the most common disease which people are suffering from. Okay, so in that cancer treatment, these radioisotopes are being used for the treatment of cancer also and for detecting the cancer also. Now radioisotopes, there are two ways in which they can be helpful in medicine field. The first is the diagnostic radioisotopes. That is, they are used, diagnostic means what? To find the cause of an illness. म्हणजे निदान करणे की हे इलनेस कशामुळे झाले आहे. इथं स्टडी करण्यासाठी काही रेडिओ आयसोटोप्स यूज केले जातात. लेट्स सी विच आर दोज आयसोटोप्स. नाव chromium 51. Okay, chromium 51 isotope. It is having 28 days half life, and it on emission gives alpha gamma particle, and it is used to study your spleen. Okay, spleen मध्ये काय प्रॉब्लेम असेल काहीतरी, if you are suffering something disease from spleen, then in that case doctors advise you to diagnostic radioisotope chromium चा आयसोटोप वापरला जातो स्प्लीन इमेजिंग साठी. ओके, स्प्लीन चे इमेजिंग करण्यासाठी you use chromium isotope. Next is for Fe59. Now this isotope is having half life period of 45 days. It also emits gamma particle and it is used for bone marrow function. Bone marrow चे जे फंक्शन आहे ते डिटेक्ट करणं, ते म्हणजे स्टडी करण्यासाठी किंवा व्हॉट डू यू से डायग्नोज करण्यासाठी, व्हॉट इज द प्रॉब्लेम इन युअर बोन मॅरो. टू स्टडी दॅट दिस iron-59 isotope is being used. Now why these two types of isotopes are being used? This, okay, short-lived isotopes are used. Why these two types of isotopes are there? Because these diagnostic radioisotopes, they are short-lived isotopes, so that they don't harm your body too much. These isotopes are injected in your body. Okay, हे तुमच्या बॉडी मध्ये इंजेक्ट केले जातात स्टडी करण्यासाठी. एखादा तुम्हाला त्रास असेल कुठला तर त्या गोष्टीचे स्टडी करण्यासाठी, स्प्लीनचा तुम्हाला त्रास असेल तर स्प्लीनचं स्टडी करण्यासाठी, निदान करण्यासाठी क्रोमियम हा आयसोटोप तुमच्या बॉडीमध्ये इंजेक्ट करून त्याचं ऍक्टिव्हिटी स्टडी केली जाते. आणि देन तुमचं बोन मॅरोचं फंक्शन असेल तर आयर्नचा आयसोटोप यूज केला जातो. वाय इट इज शो? बिकॉज दिस आर शॉर्ट लिव्ड आयसोटोप्स. त्यांची ऍक्टिव्हिटी लगेच संपून जाते. यू कॅन सी इट इज हॅव्हिंग व्हेरी small half life, 28 days and 45 days. So they do not make much harm. त्यांच्यामुळे जास्त तुम्हाला harmful, it does not harm your body too much. So this, for diagnostic radioisotopes, short-lived isotopes are used. And next is, we have seen that the radioisotopes in medical field, there are two types of radioisotopes. One is diagnostic radioisotopes, that is they are used to find the cause of an illness. Illness कशामुळे झाला आहे त्याचं निदान करण्यासाठी काही आयसोटोप्स वापरले जातात. आणि some isotopes are called as therapeutic radioisotopes, that is they are used to treat the diseases. Now we know that many cancer diseases, many radioisotopes are being used for cancer treat करण्यासाठी तुम्हाला radioactivity therapy, chemotherapy दिली जाते, तिथं radioisotopes यूज केले जाते. Okay, in chemotherapy your radioisotopes are being used. So let's see what are the isotopes which are being used for the treatment of different types of cancer. Now phosphorus 35. This isotope is having half-life period of 14 days and it emits beta particle and it is used in the treatment of leukemia, that is your blood cancer. Okay, now cobalt 60. This isotope is having half-life of 5.3 years. And these particles emitted are beta and gamma, and it is used for the cancer treatment. Third is the iodine 131 isotope. It is having half-life of 8 days. It gives us beta and gamma particles after emission, and it is used in the treatment of thyroid cancer. Okay, and last one is your radium isotope 226. It is having half-life of 1620 years. It emits beta and your gamma particles and it is used in treatment of your tumors. Okay, so these four radioisotopes, they are called as therapeutic radioisotopes. They are used in treating your diseases. Okay, so these are the four isotopes. We have seen today the application of our radioisotopes, and we have seen first application in radiocarbon dating and second in medical field. That's all for this lecture. Thank you.